So you guys have probably heard that debate before. Are you better off using water cooling or dry cooling for your facility to reduce the environmental impact? Big surprise. The answer is it depends. But we're going to take you through a couple different scenarios and hopefully leave you guys with the tools that you need to ask the right questions to understand what's the best for you for each individual project or location. So Bart Stewart, I'm a managing director of the DC, Baltimore, and um, and Bay Area offices. Mechanical engineering background. Been working in the data center industry for almost 20 years, 15 of which have been spent at WB. Jimmy, looks like you're back.
Yeah, sorry about that. That might be a problem. I heard you announce that I locked up. I could hear that, but you apparently couldn't hear me.
Yeah.
I'm Jimmy Sneed. I'm a managing director and managing principal for WB. I run our mission critical practice, our critical facilities. 15 years with WB and 30 plus years in the industry. So happy to be here to help with this.
Thank you.
So a brief introduction to what we're going to be talking about today. We all know there's a lot of concerns with data centers and the impact environmentally. And for years, we've been talking about the power efficiencies, but we've really, in the last few years, turned more of an eye towards carbon efficiency and water efficiency, in particular, what we're talking about in this seminar. So in Northern Virginia, there was a something it was a group established by a lot of environmentalists to particularly to protest the development of data centers in the state of Virginia. And that's something we're seeing across the country, not just unique to Northern Virginia. So things like we're doing here, needs to happen for our general public too, which is just education about what's going on and how we're addressing these concerns. Report.
Um, so you've probably heard of water use issues coming up. That you see headlines every now and then about some big Google data center that uses 1 million gallons of water every day. Those are real things. They're not really exaggerated numbers, and it's not a particularly good look for our industry. So the number one impact on the water use, of course, is heat rejection. Um, so this is the way we remove heat from the physical data center itself. Um, do we use evaporative cooling, which uses local water but less electricity? Do we use dry cooling, where we're not using the local water but use more electricity? So again, by the end of this, we hope that you'll have the questions to ask, both of internally in your company about your project site, questions to ask your consultants to get to the right answer for your particular site. So to start off, I'm going to give you a little overview of the three primary heat rejection methods and how those impact the water use and electrical use. Start off with traditional cooling towers. These have been around forever. They've been the workhorse of the industry since its inception. Um, Water use efficiency of 1.71, that's WUE, is a typical metric that we use in the data center world. We're talking about how much water we use uh, per cooling liters per kilowatt hour, and that kilowatt hour is the cooling that we need to do. This almost 4 million gallons of water per year per megawatt. So that's where you get these, if you look at that over the course of a day, when you're looking at these 50, 100 megawatt facilities, those numbers of, 500,000 to 1 million gallons of water a day are real numbers. And then to go with that, the fans on it are going to be using about 66,000 kilowatt hours of electricity per year. So then jumping over to hybrid systems. So these have become very popular. These come in a couple different forms. These are, wet, dry, adiabatic coolers that are similar to a dry cooler, but with an adiabatic component to it. Or there are chillers that have adiabatic pre-coolers mounted on them. What's very cool about these is they a lot of times have controllers that allow you to set it up in different modes. So if you're in an area with less water, you can set it in a water saving mode. You can also set it in energy saving mode where it's going to use a little more water, but really balance those two. And these generally do run dry when they don't need to run wet. So when it's the peak times of the year, peak temperatures, they're going to run wet. And then when it's cooler outside and there's less of a benefit, they're going to run dry. So water use efficiency of 0.11. So that's, less than a tenth of water being used by a traditional cooling tower, but substantially more electricity being used. You don't need to memorize these numbers. We do have a couple summary slides coming up. And last but not least are straight air-cooled systems. So these are going to be your air-cooled chillers and your traditional dry coolers primarily. Big surprise, zero water used. Zero would be your water use efficiency, but they use the most electricity. Not a big surprise. So just a little summary, you can see, the cooling tower that uses the most water is also going to use the least electricity. Your hybrid systems are in the middle, air cooled, most water, or least water, most electricity. All of these are megawatt hours per year numbers.
So I'll touch on the power side. When we introduced ourselves, on the board is the mechanical technical lead, basically for all of our data centers. I'm the electrical data lead for everything on data centers, and so naturally, I wanted to talk about the power a little bit because it's great to reduce the water usage, like removing the cooling towers and going with air cooled chillers and things is great from a water perspective when you're looking at it at the site. But the way we look at carbon and the way we look at water, we have to look at it with a holistic view, right? So we need to see the changes we're making at the site. What is that doing at the power plant? So yes, we're reducing water, but we're increasing power, which in turn is increasing CO2. CO2 is, obviously one of the main things we're worried about. There's a triangle that we look at: PUE, WUE, which we're talking about, and CUE, all efficiencies: carbon use efficiency, power use efficiency, and water. So when you look at the different power generation technologies, obviously coal and gas are the ones that were producing a lot of CO2. The other clean energies were not. But then there's a water component as well. So you've got to look at how much water it takes to create this. Coal and gas, which we see a lot, pretty high on water usage, not as high as hydro. Hydro's crazy out there for obvious reasons. And then solar being wind being the least, and solar being there as well. So you've got to be able to take all of this and weigh it together to understand a complete water usage, just like we do on the carbon side.
Thanks, Jimmy. So the next three slides are layered together so you can see how everything stacks up in that holistic view. As you see, while generating power from fossil fuels does use water, it is relatively inconsequential compared with the amount of water being used by cooling towers. So hydro, on the other hand, uses dramatically more water, which can be a big issue. Thinking about Lake Mead and the Hoover Dam. Lake Mead is the primary source of drinking water for that whole region. So any water they are using at the Hoover Dam is now water that is not able to be drunk out of Lake Mead, and Lake Mead is dropping in noticeable and consequential ways. So when you look at that hybrid system, the water use from power becomes a bigger percentage and a bigger absolute number. But you'll see that the total water use is still dramatically lower than the cooling tower solution, even once I factor in the extra water needed to create the electricity. And then taking that a step further with the air-cooled system, again, because the water use at the data center is so high, even when I factor in the total water used to create the power, I'm still have net net reduction in the total water that is used by the system. So in this coal example in the middle, and by the way, whether regardless of the fossil fuel that you're burning, they are generally fairly similar from this perspective. Coal versus nuclear versus gas. So we picked one in the middle, just so we don't bury this slide with similar information. So our total water use there includes the water at the facility and the water at the power plant. And that's going to continue to go down as you reduce water at the facility. Of course, the carbon um, emissions is going to go up considerably. And then the one outlier there you can see is hydro. Those air cooled systems using a lot more electricity. When you have a system like hydro that uses tremendous amounts of water, um, that will still be the outlier when you're looking at those dry systems, and which is the net overall water uh, water stealer. All right, so how do we hit that balance? We've looked at the background numbers, but every site's a little bit different. And the answer, of course, is we got to look at the location. So the most sustainable data center is going to depend on water availability at your particular location. So we're going to start geographically. You got to start there. How much rain is actually comes down in that particular area, and we'll talk about site constraints a little bit later. And that's the general idea that just because there's water in the region doesn't necessarily mean there's water right here, right now in the water mains. The number on the map indicate the number of data centers in that state. And just for clarification, that number, the location within the state, it's just kind of the center of the state. It's not indicating where that data center hub may or may not be. So the colors on the graph indicate total annual rainfall of those. And you can see, big surprise, hit a lot more in that, southeast, east, and Pacific Northwest, much drier in the Midwest. So, it might jump out at you, hey, let's build in the Southeast. Why aren't we building a lot of data centers down there? Well, the short answer is hurricanes. The increased risk of natural disasters in these areas makes it much more expensive to build data centers. And then any environmental benefit you get from that, you're often going to lose by running your generators a lot more often, due to the high frequency of power outages associated with natural disasters. Personally, I love the Pacific Northwest. Very plentiful water supply without the same challenges with natural disasters. But you get this similar condition in the Northern Virginia market. We have plenty of rainfall with minimal natural disasters, and that has been a contributor to massive growth in the data center industry there. Um, Obviously, not the only one. Fiber infrastructure probably being the single biggest, but having that low natural disasters, high water, high power, being close to an airport, all of those things factor in. That's really led to that boom there.
Yeah, and it's the cost of the power too is a big one.
Yeah,
That's why we see them there as well.
yeah. Um, the Carolinas are in a similar position, that north and south. Once you get away from the water, the hurricane risks drop dramatically, but the rainfall is still pretty high. And so that's, again, a contributing factor to the increase in data center development in the Carolinas. All right. So, how does that apply to your particular project? A lot of times we're given project locations already. By the time a project makes it to a lot of us, people, on the call, people like me, the site's already been picked. They bought the land years ago. Now we're ready to develop it, or there was a separate site selection process that's already been completed. And now we're stuck with that site, and we got to figure out what the best answer is for our site. Um, so we're going to talk about a couple different scenarios for you, and talk about some examples of projects that we've seen that have gone sort of one way or the other, and why we have done. So first off, if you're in a climate where your energy source is clean and your water availability is low, that's a fairly easy answer. You're going to want to use electricity every time. We have a client in Arizona who's not only using solar power, but has actually chosen to go a step farther and get into the solar energy business, using land that they've chosen not to develop for other purposes. So I know what you're thinking. Hey, Bart, our facilities pull the same megawatts during the day as they do at night. So where's that power going to come from? And you'd be completely right, of course. Um, but they do end up buying natural gas power at night. But this actually does help one of the big challenges of the power generation business. And that's really how our power fluctuates during a 24-hour period. So to illustrate that point, I'm going to jump over quickly to this helpful graphic I found from the IMF. So this is really focused on peak shaving, but the exact same principle applies. Um, if you can raise the trough at night without contributing to increasing the peak during the day, it goes a long way to helping the utilities run their most efficient plants um, more and rely less on your peak plants. You know, your peak plants are your oil plants, things like that that can turn up quickly. Those are going to be your least efficient plants that are expensive to operate, and generally the dirtiest to operate from really every metric. So anything that we can do to keep those peaks down and keep that trough up, allows those bigger, your nuclear plants to never turn down, things like that. They can just run all the time and continue to pump out, high efficient, low cost energy. But when we have those big peaks, you're not taking a big nuclear plant and turning it up and turning it down all the time. So you end up having to use extra, additional technologies that are more expensive, dirtier, louder. Um, so anything that we can do so that is why solar then becomes feasible for data centers is, yeah, it's not going to work all night, but it is going to really do a lot to sort of flatten out this curve. So jumping back to this whole table, on the other end of the spectrum, you've got um, high water use and high CO2 energy. So back to the Northern Virginia market, this is another good example where we have plenty of water, but our electricity is predominantly natural gas. So in that case, we really want to use water all day long. That is normally a hybrid system, so we don't put an unnecessary burden on the local distribution. As you saw with that hybrid system, you get a lot of the evaporative benefits at a much lower water premium. But then you have places like Ashburn that, it's that huge data center hub. They've actually taken it a step further, where they have this county-wide distribution loop. They call it their pink water loop, that is purely for evaporative cooling. And it is not a potable water source. So you're bringing two water services to the building, but you're going to bring like a 2-inch water service for your bathrooms and your kitchens and things like that. And then you might have a 6-inch water main, 12-inch water main coming in for your makeup water, that is not potable water. So it is not nearly as heavily treated, which makes it a lot less expensive. They can use different sources for it, and it's able to bring you that same kind of cooling water and much less of an environmental impact. Unfortunately, the folks on this call probably are not influencing those decisions to put in those loops. But focusing on areas that have infrastructure like that specifically designed for supporting data centers is really helpful for not putting an additional burden on that local system.
Yes. So
And looking at the high water availability and low CO2, Jimmy is going to tell us about one of his clients in the Pacific Northwest and how they navigated this choice.
sorry, Bart, stepped on you a little bit there, but yeah. So Bart spoke about it a little bit earlier that the Pacific Northwest, we have a lot of water, a lot of rain there, and they create a lot of their power with hydro, so low CO2 output for the way they create their power. And this is something similar that through our research we were looking at South Carolina. Lots of rain in South Carolina, and 55%, I believe, is what Bart found that of their power is nuclear. So obviously, very low CO2 output. So we had a data center client in the Northwest, and traditionally using wet systems, not cooling towers, but something with a lot of water, rooftop units, big rooftop units that used a lot of water. The way that they operated their system, they got really interested in the fact that they were getting energy efficient, but how can we get water efficient as well? So the first thing that everybody thinks about is, yeah, let's just shoot straight to air cooled chillers. Let's go completely waterless, and see how that flies. And then as you start looking into yes, we've reduced water, as Bart mentioned earlier, we're actually the water usage for the power is not a huge concern, but the CO2 that the plant was offsetting, because this particular client was really looking at their level 1, level 2, level 3 carbon emissions, which are very important to them and is very important to a lot of our clients and probably a lot of you guys on the call. So we came back and probably settled more on the hybrid system that Bart was describing earlier, still using some water at the site to reduce that energy usage, which is also reducing the CO2. So I think the point, and as Bart will go through one more example here, is there is no one answer to any of this. We've got clients that look at it different ways, and really it's being smart enough to ask the questions and find out what your clients, their energy goals are, and helping educate them that sometimes they think about one thing but maybe not the other. So being able to ask the right questions is so important.
Yeah, it's interesting seeing them go kind of from one end to the other and then sort of end up back in the middle.
Right.
I think it's a very relevant story that's probably relatable to a lot of people here.
Yeah.
So the last one I'm going to talk about is the so the scenario here is you've got a dry climate. In this case, there's a surprising amount of data centers in the Phoenix, Arizona metropolitan area, that region. Water is scarce. They burn a lot of natural gas for their power. So you have a relatively high CO2 power scenario. Um, so what do you do if you're in a place like Arizona where you're sort of stuck between high CO2 or water usage? Um, so you're going to start looking at other factors. So we had a client in the Phoenix area, not the ones who decided to go solar. Pure dollars wise, they figured out they'd be better off using water for a hybrid system. But in exploring the water infrastructure and knowing how protective the local community was about their water, they opted to go fully dry because it was not worth the money for them to end up in the local newspaper with a front page article about how much water they were using. So that idea of being stewards to the local community, understanding what the local community feels about things, was really important to that decision. Um, and then the last piece of that is really understanding what your own company's sustainability goals are. Um, Most companies have them. Every big company has sustainability goals. If you don't know what your company's sustainability goals are, you should probably find out. They almost certainly exist. Are they more CO2 focused? Are they more water focused? Do they exist? They don't always exist. So all of these will need to be factored into your decision. So a couple of key takeaways. So, hitting the balance, um, not just for your own project, but collectively, as an industry. We need to be able to show the world that we actually are trying to reduce the environmental impact of data centers. Because as much as people like to use technology, people like to use Chat GPT, it's a not in my backyard situation. Everybody wants to use it. Nobody wants to be near the data center that is allowing it to happen. So the more we can do to minimize the impact on the local areas, especially those more scarce resources, it's going to go a long way to reducing the pushback that we get from folks who don't want data center developments near them. And then, kind of taking that a step further, once you've made that decision, anything you can do to be proactive with your local communities and educating them on the steps that you are taking is going to go a long way to make sure that they appreciate the steps that you're taking. Because if you take those steps and nobody knows about it, you're losing that kind of PR benefit of taking those steps. And then, of course, there's no one size fits all solution. But hopefully, think about that chart and kind of where you are on that chart will help you ask the right questions, really about understanding where your power comes from, understanding where your water comes from, understanding what the local constraints are for your site. If you understand all of those, you can be confident that you're going to come to the right answer for your projects. And with that, we will open it up for questions. And actually, we didn't see any in the chat.
Yeah, there was nothing in the chat.
Either everyone's asleep or we crushed it. I don't know.
Hey, gentlemen, this is Jeremy Brown, First Citizens Bank. Can you hear me?
Hey,
Yeah.
Jeremy.
Jeremy.
Hey, appreciate y'all taking the time putting this together. Excellent presentation. And I guess I don't really have any questions based off the data you provided outside of if you were to build a 10 megawatt site, where would you build it and why? Top two factors.
Yeah, so that's a great question. And it's a different answer if we just think about it in this particular lens. If we're just thinking about it in this particular lens, there's still that, that north mid-Atlantic corridor, sort of before you get down to the hurricane zone, but staying a little bit off the coast. That's really where you're going to go if you're not going to go in Washington State. I'd personally stay away from Arizona, Colorado, Nevada, all of those areas that have a lot more water pressure on those systems, especially the ones that have a lot of people in very dry areas. I again bring up Phoenix. There's a lot of people in Phoenix. Phoenix is really blown up between Phoenix and Scottsdale and Tempe and all of those surrounding areas. It's already put tremendous pressure on that water supply. And so, adding more pressure is not a good situation for those areas. And then, kind of in that mid-Atlantic, you've got good access to airports, you got low natural disasters, you got good fiber infrastructure, although that's sort of in hubs. So if you're not careful, you can end up in a spot where you got to run fiber miles and miles to get it to another hub.
Mhm.
So
Yeah.
that's my short answer to a long question.
That's a very political question too, Jeremy. It's a good one. But I think I'm still a big proponent of Northern Virginia. Obviously, if they could work out their power issues, and really, it's where that we're getting the tax incentives too to build. And even though it's not ideal on water and maybe chances of tornadoes, but Texas is big on my list right now just because of all the stuff that they're putting in front of owners to try to tempt them to come to Texas. But there's some challenges there. But yeah, like Bart said, looking at it strictly in the lens of water, yeah, then clearly we would want to be. I like the Southeast a lot. I think that new corridor in North Carolina is going to be big for many reasons, and so I would not be at all shy to go there.
Agreed.
Thanks, gentlemen. Appreciate it.
You got it.
Any other questions?
No, just bill ceiling over here in Verizon land. Nice job, you guys. Really appreciate it.
Thank you. Appreciate that.
Right. Okay. Well, I think we've wrapped up a little bit earlier. So we'll give everybody, their 30 or 25 minutes back, but we appreciate you guys joining. And there's a QR code on here too. If you get a chance, if you could scan that and it'll ask you some questions, maybe just to rate the seminar to see how, or the webinar to see how you liked it, and anything that you would like to see different. And also Bart and I's contact information is there. Please feel free to reach out and talk to us. I know Bart's the same way I am. I love to talk data centers, and we'll talk all day long about our opinions and what we're seeing. And Bart mentioned it at the start when I was locked out. I'm in Cairo today. I've been in Cairo in the Middle East looking for places to build data centers as well. So I'm always doing that and always willing to talk about it. Anything else, Bart, you want to add?
All set. Thank you, Jimmy.
All right, everyone, we'll turn you loose. And again, thanks for taking the time with us today. And we look forward to talking to more of you in the future. Thanks.
Thank you, gentlemen. Appreciate it.
Take your time.
Thanks.